Good morning everyone, my name is Lloyd, and for our report for today, I will discuss about geometric design of hill roads slash highways. But since our time is limited, I will only discuss the topics that are important in geometric design of hill road. So for the geometric design of hill roads slash highways, cross-section element, site distance consideration, and horizontal and vertical alignment are supposed to be designed. The first thing to be considered is pavement characteristics. The pavement is the uppermost layer of the highway, in which longitudinal friction is taken to be 0.35 to 0.4 and the lateral friction is taken to be 0.15. So in making the highways should not be a light reflecting one in day, but a light reflecting one in night. That's why we design highways with a black topping and white margins, because white margins reflect in night and it helps the driver to see the road in night because we have the white margin as a guide. Now, the allowable unevenness in the highway should not be greater than 150 cm per kilometer. So coming up to the cross-section element, highway is divided into two, the pavement and the curbstone. The pavement is having a slope which is called as camber. So the slope is for reading the surface water. The slope is provided in terms of theta and calculated in terms of n, where camber is equal to 1 by n percentage of tan theta. Now, if I'm talking about the camber is consists of two types. The first one is a triangulated camber and the second one is the parabolic camber. Triangulated camber can be calculated as y is equals to w upon 2n, and the parabolic camber is y equals to 2x squared upon wn. There exists a distance from the side, and y is the height of the camber, and w is the width of the pavement. Now, there is the term that the gradient is twice of camber. But talking about gradient, whenever the road turns out to be a vertical turn, the vertical height is known as theta, which is gradient, and the vertical slope means the camber, which is provided as theta. It is known as camber. So this is our highway going up as a gradient now, and this is our camber, which is in terms of theta. So gradient is equals to twice of the camber. Now, coming up to the allowable camber. As you can see here on the table, for cement concrete pavement, for heavy rain, 2% of camber is provided, while for low rain, 1.7% of camber is provided. Same goes with the other pavements. For bituminous road, 2.5% for heavy, 2% for low. For waterbound macadam, 3% for heavy and 2.5% for low. For eastern road, 4% for heavy and 3% for low. Now, coming up to the design of width of pavement or carriageway. The total length in which our main essential highway is constructed is known as width of formation, which is the 12 meters. It consists of two pavements, one median where the plantation is done, and two shoulders just along the pavement lines. At 45 meters on both sides, there will be a road boundary. At 80 meters, there will be a building line. And at 150 meters is the control line, and this complete 150-meter control line, which is known as right-of-way. So the actual width of the right-of-way of our whole pavement is 150 meters.